I want you to take pictures of these notes and put them in your Google Classroom for a daily grade. So you don't need to write down these equations on this first slide, but I do want you to just title it. If you're taking your own notes, here's your title: Graphs with one transformation. And then there's a list of all the parent functions. These are the basic shapes that we just covered. And again, you don't have to write all those down. The reason why they're on the slide is from past years when this was like a new days lesson and we were just taking a minute to review the parent functions. So what we're going to be doing in this lesson is taking the basic shapes and doing one transformation on them, moving them left or right, or up or down, a reflection over one of the axes, or stretching or compressing. We'll do one at a time, and we'll talk about the different places that the equation would be modified in order to make that shift happen, okay? Because it's different ways that you change the equation results in different modifications in the shape of the graph. And we're just doing one at a time today. On our lesson Thursday, we'll be doing multiple transformations at a time. And so this is why I was telling you, the faster you can review and memorize those basic shapes and their points, their ordered pairs, the easier the rest of the lessons will be. If you don't spend the time doing that, you're just going to be continuously frustrated for the rest of this unit, okay? So don't write this down here. I want you to just look. This y equals AF x minus h plus k is a general form for different modifications you can do to a basic function. Like, for example, if there's something inside with the x, that's a horizontal shift. That's an insider's lie, right? You're going left or right. If there's something outside with a k, that's your vertical shift, up or down. If you're multiplying something at the very front of the function, that's going to either stretch your graph or compress it and make it fatter. And then if a is negative, it reflects over the x-axis. And then if x is negative, like there's a negative and right directly in front of x, it reflects over a y-axis. Okay, and these are all things we're going to be talking about in the examples. And we're just going to take those one at a time. The yellow thing, the purple thing, the blue thing, the red negative. We're going to look at those individually. The first one we're going to talk about is h. Okay, so the things I'll just highlight the major things I think you should be writing down, because the rest you can go read more carefully later. So h you will find inside being subtracted from x. Okay, and what we mean by inside is it's going to be inside parentheses or absolute value, or it's going to be inside the root if it's a square root or if it's a cube root. It's always going to be attached right next to the x. It's going to be grouped with the x. And this is your horizontal shift left or right. So here's the next slide. H shifts your graph left to right, and it follows the insider's lie shortcut. So if you have 5 being added to your x and it's inside parentheses, then what that means is plus 5 actually means you're going to the left 5. Yeah. And the reason why insider's lie is just for x is because you're still wanting when you're just You know, I'm not even going to say what I'm about to say. You don't need more information. Sure. You're welcome. Mm-hmm. Yeah, all the pages, because we are writing stuff down. Anything where you had to write stuff, that's what I want. You're welcome. Okay, so here's an example of just H. So the reason, so this is an example of H, not K, because the thing that's being added, excuse me, the thing that's being added or subtracted is inside with the X. It's inside the absolute value. But what I want to do first actually is graph the original function before it had a +3, okay, the parent function, because we're going to use that to do our transformation. So what function was this before it had a +3? Absolute value, right? So let's just graph the basic shape of absolute value. Before any modifications were made on it. So that's a basic absolute value. +3 inside the absolute value is an insider's lie, and it's a horizontal shift, which means everything is going to go to the left 3 places. So, and the reason why that works is if you put -3 in for X, you get 0, right? So when X is -3, Y is 0. Where did the origin go? It shifted to the left 3 places. And that's going to be true for every other point. You could make an XY table for the X +3. But knowing these shifting patterns just makes it go faster. If you just know everything goes to the left 3, then you just draw it faster that way. And so this is H, horizontal shift. The left or right shift. The next one we're going to talk about is A. You will find the A value multiplied outside the function. Okay, it will be right after the equal sign. And what A does is it stretches or compresses the graph. Because what's really happening here is whatever your A value is, you're multiplying your Y's by that. It's changing your output value. And so if you're changing the Y, you're either making your Y's bigger or smaller. So if A is bigger than 1, it stretches your graph. If A is smaller, it makes it fatter and shorter. And if A is negative, it reflects your graph over the x-axis. Because if it's negative, and it's what you're multiplying your y's by, so if y is positive, now it would be negative. If y was negative, now it would be positive. So it's flipping your graph like this. So here's an example. My parent function, before any modifications were made, was x cubed. So I'm going to graph that basic function. I'm just going to use 3 points. I'm generally pretty happy with just 3 points. I know some teachers might want more. So an A value means you're taking the y's on those points and multiplying it by -2. Your x values will stay the same. So for example, this point right here is 1, 1. X stays the same, the y gets multiplied by -2. So your new point for your modified, is that a word? That's not a word. Modified, okay. I don't know if I want to say modification or what I want to say. Your modified point, x stays the same, so it'll be 1, but the y becomes -2. That's what the A value does. It multiplies the Y values by itself. And then this point right here, that's at -1, -1. The X stays the same, but the Y value gets multiplied by -2. So when I take the Y value and multiply by -2, it becomes +2. So my X stays the same, but my Y becomes +2. And then the 0, 0 point doesn't change, because you can multiply 0 by -2 and it's still just 0. So it's a little bit hard to tell because 2 isn't a huge change, but this graph has been stretched taller and the negative made it reflect. I know that's a terrible, terrible drawing. I apologize. I hope it doesn't bother your sleeping this evening. It's kind of twitchy. It's really ugly. But that's what happened. It stretched a little bit because 2 is greater than 1. If the A value had been a fraction, like a half, what would have happened is my graph would have got shorter and fatter instead of longer and leaner. And I think we have one more, right? Example. 2 more? Oh, let's do it. We got 2 minutes. 1 minute per problem. Okay, we got it. K. K is a vertical shift. It's always going to be on the outside of your function. And it's not an insider's lie because it's not inside. So whatever the K value is, that's how much you go up or down. And you don't have to do opposite. So the parent function here is x squared. So let's just do 0, 0, 1, 1, -1, 1, just to be fast. It's a parabola. And a K value of -5 means everything shifts down 5 places. That's it. Super simple. So my vertex goes down to -5. And we have one more, right? Okay. I'm going to go straight to it. I know I'm rushing. I apologize. So this one says when x is negative, so there's a negative somewhere like right in front of your x, it's going to reflect over the y-axis because you're taking the opposite of whatever x was. So in this example, the parent function is square root. So that looks like this, 0, 0, 1, 1, 4, 2. Well, if x is negative, you're taking each x, your y stays the same. You're just taking the opposite of x. So 0, 0 stays there. 1, 1 becomes -1, 1. 4, 2 becomes negative 4, 2. You're just taking the opposite of x. Okay, sorry I rushed that. These notes are your daily grade. Have a wonderful day. See you Thursday. Bye. You'll have a good day. I'll wipe your desk, Holly. Yeah, because I know you have to go. Do y'all have time to help me wipe your desks? Okay, great. Thank you.
It's so small. So I don't read my notes. I can't still
One new student. Let's see if she stayed in. No, she did. Oh, I forgot to pause.